Imagine, every second thousands of users visit your website. Every click, every mouse movement, every scroll, that's data. Golden data that can tell you everything about your customers. But there's a problem. How do you process this stream of data, enrich it with customer information, and not bring down the entire system? Today we will analyze a real case study, 4 architectural solutions, and only one of them is correct. Let's get started. There's a company, let's call it Best Shop, a major e-commerce project with millions of visitors per day. Their marketing team comes to the architects and says, "We need analytics. We want to know what our users are doing on the site, where they click, what they view, where they leave. And we want to see this alongside customer profiles, how much they've spent with us, what their purchase history looks like." Okay, sounds simple, right? But let's break down what this means technically. First, we have Clickstream data, a stream of clicks from web servers. The company has already configured sending this data to Amazon Kinesis data streams, so the data stream is already flowing to the cloud. Second, the company has a customer database in Amazon Aurora, a powerful cloud-based PostgreSQL or MySQL, and it contains profiles, names, purchase history, customer segments. Plus, the database is configured in multi-AZ mode, meaning it's replicated across multiple availability zones. Reliable. Third, the company wants to analyze the enriched data in Amazon Redshift, a powerful analytical data warehouse for big data. And fourth, the most important part, the solution must be highly available. This means no crashes, no downtime. The system must work 24/7. So, the task is clear. Take the clickstream from Kinesis, enrich it with data from Aurora, send the result for analysis to Redshift, and do it in a way that the system never goes down. Let's look at 4 options the architects proposed. Option A. Use AWS Lambda to process and enrich clickstream data. Lambda writes results to Amazon S3. For analysis, use Redshift Spectrum, which queries data directly from S3. Option B. Spin up an EC2 Spot instance. These are cheap virtual machines. It pulls the data stream, enriches the clickstream, and sends results directly to Redshift via the copy command. Option C. Use Amazon ECS with Fargate Spot. These are containers without server management. The container pulls the stream and enriches the data. A separate EC2 instance executes the copy command to load into Redshift. Option D. Kinesis Data Firehose automatically loads clickstream from Kinesis streams into S3. AWS glue crawlers determine the data schema and populate the data catalog. Amazon Athena queries raw data from S3. So, before you are 4 architectural solutions. A. Lambda, S3 and Redshift Spectrum. B. EC2 Spot with direct load to Redshift. C. ECS Fargate Spot and EC2 for copy. D. Firehose, Glue and Athena. Remember the main requirement. The system must be highly available, not a minute of downtime. Which option will you choose? Write your answer in the comments right now. A, B, C or D. You have 15 seconds. Let's start with the most obvious mistake. Option B, EC2 Spot instance. At first glance, looks great. Spot instances cost up to 90% less than regular EC2. You save a ton of money, get computing power, everyone's happy. But there's one but, and it kills the entire architecture. Spot instances are like taxis during rush hour. Amazon can take them back at any moment, literally with 2 minutes notice. Imagine, your system is processing the clickstream, enriching data, everything's working, and Amazon says, "Sorry, I need these resources. Bye." Your instance dies, data is lost, the stream stops. Marketing is frantically calling the IT department. This is the complete opposite of high availability. Spot instances are great for batch jobs, for testing, for tasks that can be interrupted and restarted. But for critical real-time processing, never. Option B, rejected. Moving on. Option C, ECS with Fargate Spot. Here the architects tried to be smarter. They used containers, that's trendy, that's serverless, Fargate. But they used Spot type again, same problem. Fargate Spot is the same Spot instances, just in a container wrapper. Amazon can interrupt them at any moment. But that's not all. Look at the second part of the architecture. To execute the copy command to Redshift, they use a separate EC2 instance. So we end up with an additional server that needs to be configured, an additional point of failure, additional operational costs. We wanted a serverless solution, but we got a hybrid that requires infrastructure management. And most importantly, where's the high availability here? A single EC2 instance without redundancy is a single point of failure. Option C, rejected. Now the most interesting case, option D. From an infrastructure point of view, everything looks pretty good here. Kinesis Data Firehose, fully managed service, highly available. S3, can't get more reliable than this. Glue crawlers automatically determine the schema. Athena, serverless query engine. Looks solid, right? But let's go back to the requirements. The company wants to enrich Clickstream data with information from Aurora. Join clicks with customer profiles. Now look at option D's diagram. Kinesis Firehose, S3, Glue, Athena. Where is Aurora here? Where is the data enrichment? This option simply ignores the key requirement. Yes, it excellently loads raw data into S3. Yes, Athena can query it. But this is raw data without enrichment. Firehose is a delivery pipeline. It cannot query Aurora on the fly and join data. And another point, the requirements specify using Redshift for analysis. But here they're proposing Athena. Option D, rejected as well. And we're left with option A. Let's break down why this is the ideal solution. AWS Lambda is the heart of the architecture. Lambda is completely serverless. You don't manage servers at all. It scales automatically. 100 events per second coming in. Lambda will launch the needed number of functions. 10,000 coming in, it will launch more. And all of this without your involvement. And most importantly, Lambda is highly available by default. AWS itself ensures redundancy, automatically restarts functions on failures, and distributes the load. Lambda can connect to Aurora and enrich data on the fly. For example, a click comes in with user ID equals 123. Lambda queries Aurora. Give me the profile for user 123. Gets the name, purchase history, segment. Joins everything together. Enriched data is ready. Now Lambda writes the enriched data to Amazon S3. S3 is storage with high durability. 11 nines. Your data is safe there. And the final touch? Redshift Spectrum. Spectrum is a killer feature. It allows Redshift to query data directly from S3 without loading it into Redshift itself. This means no need to wait for ETL processes, no need to pay for storage in Redshift. Data is available for analysis almost immediately. So Kinesis data streams receives the Clickstream. AWS Lambda processes events, queries Aurora, enriches the data. Amazon S3 stores the enriched data. Redshift Spectrum allows analysts to query the data. All serverless, highly available, scales automatically. Option A is the correct answer. Let's summarize. If you guessed right, great. Write A in the comments. If not, don't worry. Now you know why Spot instances are not about high availability and why Lambda is like a Swiss Army knife of AWS architecture. Subscribe to the channel if you want more architectural breakdowns like this. Every week, a new case, a new puzzle, new knowledge. And remember, good architecture isn't the most complex architecture. It's the right architecture for the specific task. See you in the next video.